point source of light, then the image formed in that case will have only umbra. No umbra will be, no penumbra will be seen. Please note down this point.
Ma'am, it's not clear. It's a bit confusing.
I'll tell you. And I suppose this is the front part of the torch through which light is emitted. Now, what I'm saying is, I will be covering this complete screen with a cloth, with an opaque cloth, so that light will not come out. So I'm covering this entire glass with a cloth and I'll be making a hole at the center. Do you understand?
Yes, ma'am. I got it in here.
So I'll be making a small hole. Now light will be coming out through this hole only. Okay. So when you view it from sideways, initially you have seen light coming from the complete torch glass, but when I just covered it with a cloth and made a pinhole, then you will see light coming only in this part. Is that understood?
Yes, ma'am.
So the condition is when point source of light is used. So what happens when I use a point source of light? And my dear students, I hope you understood what is meant by this point source. So when I use this, only umbra is formed. When point source of light is used, you will see only umbra. You will not see penumbra in this case. Okay. And shape of the shadow is same as the object. The shape of the shadow will be same as the object. If you are taking a ball, the shape of the shadow is also circular one. You get a circular shadow. If you are taking something in rectangular shape, if the object is of rectangular shape, the shadow will also be of the same shape. Did you understand?
Yes, ma'am.
Yes. And very importantly, shadow is bigger than the object. Shadow will be seen bigger than the object. And you will see these characteristics for a shadow when you are using a point source of light. Is that understood?
Ma'am, I have a doubt. Ma'am, that when electricity is gone in a house, we lights a lamp. That time we make shadows and all, or we see our own shadows. So that time it is bigger than us. So what does it mean?
It depends on the distance of the object and the light. It also depends on the distance between object and the screen. Screen means in the sense on which your shadow is falling.
Okay.
Did you understand? Okay. Now that is what I'm going to tell you, Nana. Now see, this is the source of light. This is the point source. This is the object. And this is the shadow. Of course, it will not have any color. You will be able to see only the shape. Okay. This is the shadow. Now, if I move the object towards the source, or see, if I am decreasing the distance between source and the object, it can be like I am moving the source towards the object, or I am moving the object towards the source. Then size of the image increases.
Ma'am, I didn't get it.
And if I consider U to be the distance between point source and the object, did you understand? If U is the...
I understood everything, but I didn't understand the last point.
No, what I'm saying is, if the distance between these two is decreasing, if I'm bringing them together, it can be by moving the point source towards the object, or it can be moving the object towards the point source. By doing something, if I'm making them closer.
The point hole and the object.
If the object is moved towards the source, or the source is moved towards the object, then the size of the shadow increases.
Okay,
Please
ma'am.
make a note of it. That is what I'm saying. This will be a little confusing because you'll be seeing many points as such. The size of the shadow increases as the distance between object and the screen decreases. Now, if I'm moving this point source away from this, now the source is here. What happened? The distance between source and the object has increased. Now, if I'm moving the screen away from the object, then the size of the shadow decreases. What happens to the size of the shadow? Size of the shadow decreases. And students, do not misunderstand it as the size of the shadow will never go smaller than the object, because you understood here shadow is always bigger than the object. The thing is, initially it became very big and now it has become small, but not smaller than the object. So I'll write it on the board for your convenience. If distance between source and object decreases, if distance between source and object decreases, and if distance between source and the object goes reverse, I mean this increases, size of the shadow decreases. Is that understood?
Yes, ma'am. Please give us a moment to just note it down.
Yeah, please. So finally, you can just mention here and vice versa.
Okay, ma'am.
So now we have seen what happens if the source or the object are displaced. Now the question, what happens if the screen is moved? I am keeping the source. Now this is the object and this is the shadow. So shadow will be casted on a screen. Now what happens if I move the screen away from the object? If the screen is moved away from the object, the shadow grows in size. The shadow becomes bigger in size.
Yes, ma'am.
Screen is moved away from the object. Please note down that point, Nana. If the screen is moved, size of the shadow increases and vice versa. Screen moved away, size of the shadow increases, and if the screen is moved towards the object, size of the shadow decreases. But the size of the shadow is never going to be smaller than the object. Is that noted, Nana?
Yes, ma'am.
So the case where you see only umbra of the shadow is when a point source of light is used. So when point source of light is used, what are the characteristics of the shadow?
Ma'am, can I ask something?
Yes.
If screen is moved away, size of the shadow decreases, right?
When screen is moved away, size
Yeah.
of the shadow increases.
Okay.
And if the screen is moved towards the object, size of the shadow decreases.
So when it is away, it will be increased, and when it is near, it will be decreased, right?
Exactly.
Okay.
And then, so let us recollect once again the characteristics of a shadow when point source of light is used. So when point source of light is used, the shadow formed by the opaque object will have only umbra region. And the shape of the shadow is same as shape of the object. Also, shadow will be always, in any case, will be bigger than the object. These are the three characteristics of a shadow. And rest are the cases. What happens when you move source towards the object, or if you move object towards the source, or if you keep screen away from the source, or if you keep screen close to the source. Those are the different cases you have seen. And in every case, you can see the size of the shadow keeps changing relative to size of the object. Okay. And then what happens if I'm not using a point source, I'm using an extended source? Like it can be a bigger bulb, it can be a tube light, because that is not going to be a point source. Okay, what if I'm not using point source? I have two chances. I have two options. One, I can take a source of light which is bigger than the object, I can take a source of light which is smaller than the object. Did you understand? See, if I'm not taking a point source, I can go for a candle, and candle can be of less size than the object. I mean, the source of light can be lesser than the object, or the source of light can be bigger than the object.
Ma'am, for example, like a tube light and a candle.
If I take a ball and say, if I consider a candle, now the source of light is lesser than the object, right? Is that understood? Is that clear? Now the source of light, because light comes from the candle, this is less than the object, which means the object is bigger than the source. Okay. Or if I take a small ball, but I use a big light, now the source is bigger than the object. If not a point source, if the source of light is not of point size, I repeat, if the light source is not of point size, just as we have seen in the previous case, it is an extended one. We call it as an, if not a pointed source, we call it as an extended source. And there are two cases arising. One source is smaller than object, and the second case, source is bigger than object. So we have to understand one by one, because there are two cases here. One source smaller than the object and the other source is bigger than the object. So we'll start with one. Understand one. And we'll understand one by one. So I'll be considering a case when source of light bigger than the object. Then what do you think? Only penumbra forms or both forms? Both umbra and penumbra forms. When the source of light is bigger than the object, the shadow will have both umbra and penumbra regions. And umbra is less than penumbra. Did you understand what I mean?
Yes, ma'am.
The umbra region will be small and the penumbra region will be big, which means the size of penumbra, you can see, is very much bigger than the umbra. So umbra is always smaller than penumbra in this case. Now, condition, if source of light is moved towards object, if source of light is moved towards the object, what happens? What we have seen earlier, shadow size increases, and apart from this, you will see a relative change in umbra and penumbra also, where size of umbra decreases and size of penumbra increases further. Now, if at all I am moving this candle away from the ball, then the shadow of the ball increases. Also, in that shadow, you will see size of the umbra still decreases. It is anyway smaller than penumbra, but it goes still smaller, and size of penumbra keeps on increasing. So you might be seeing a shadow something like this, where if initially the size of the umbra is this and the size of penumbra is this, but once I have moved source of light towards the object, I can see size of the umbra still decreases and size of the penumbra increases.
Ma'am, that means when you bring the object and the source together, like nearer, that time the penumbra increases and the umbra becomes smaller, right?
Decreases, exactly, dear. And vice versa. I mean, the reverse happens if you just change the thing. I mean, here you have seen If source of light is moved towards. Now, what if the size of, if the source of light is moved away? If the source of light is moved away from the object, shadow size decreases and size of the umbra increases and size of penumbra decreases.
Ma'am,
Did
please, I'm just noting it down.
I didn't get it, yeah?
Ma'am, I'm just noting it down, please.
Please note down. Is that noted?
Yeah, ma'am.
So the other case, see, let us recollect what we have learned in this case. When source of light is bigger than the object, like you are taking a candle and the object is of a football size. It's just an example. The object is far bigger than the source of light. In that case, you will get a shadow which will have both umbra and penumbra. And in that shadow, umbra size will be less than penumbra size. The size of the umbra is less when compared to size of penumbra. And then we have also understood that if the source of light is moved away from the source, away from the object, shadow size decreases, size of umbra increases, and size of penumbra decreases. And quite opposite, when source of light is moved towards the object. I hope all the points are noted.
Yes, ma'am.
Yeah. So I'll just change the condition here. When source of light is smaller than the object. Now the case when source of light is smaller than the object. Now in this case also, dear, you will find both umbra and penumbra. Okay, and you will see size of the umbra being bigger than the size of the penumbra. We have changed this condition. The source of light now has become smaller than the object. And both umbra and penumbra forms in the shadow. And here, compared to the earlier case, a reverse happens where size of the umbra becomes more than size of the penumbra.
Ma'am, actually, this umbra and penumbra are opposite to each other, I think so, in many statements.
Yes, yes. Now, let us get into the conditions. If the source of light is moved towards, if the source of light is moved towards.
Ma'am, I would like to ask something.
Yes.
Ma'am, that in this case also umbra is smaller than penumbra.
In the earlier case, umbra is smaller than penumbra. In this case, umbra is and you are talking about this one.
Yeah, the small now the source of light is smaller.
But it's a reverse runner. Both the size of the shadow.
No, I'm asking about the umbra. Umbra will be greater than penumbra, or penumbra will be greater than umbra.
Umbra will be greater than penumbra, but here this relation holds the same, but the size of umbra also increases and size of penumbra also increases.
Okay.
Both increasing relative to these things. I am not saying that umbra goes, now here the situation gets reversed and penumbra will go bigger than umbra. I am not saying that. This condition will hold good in any situation, but relatively, when compared to their earlier sizes, when this happens, both the sizes will be increasing. Both umbra and penumbra size increases.
Ma'am, then still the umbra will not be higher than the penumbra, right? It will be higher, but the size of the the umbra will be not greater than the penumbra, right?
Even now also, umbra will have a bigger size than penumbra.
Can you just draw the diagram for a better clarity?
Actually, I have downloaded a video, Nana, but unfortunately it's not playing. I thought that video can help you understand the situation better. But chalo, anyhow, I'll be looking for a better video for you guys in the next class. Got it? To understand the same scenarios.
Okay, ma'am.
Yeah, I'm honestly saying I have actually taken few videos which explained very the situation. But then they're not permitted to play outside the YouTube. So I'm not able to show you them. Got it?
Okay, ma'am.
Then we'll be having a quick revision on what we have learnt in today's class. We have learnt about what is meant by.
I still have a doubt.
Yeah, please.
Ma'am, if in the case when the light is smaller than the object, if source of light is moved towards the object, shadow size.
What happened? Shadow size.
After that, what do we need to write? Because I was noting it down that time. You opt your webcam.
Exactly. I thought of revising.